Today, we have Chris McGuire from the Nature Conservancy, and he is going to talk about the technology that goes into finding fish, maintaining fish, sustaining fish, and a whole bunch of other things around that. The Nature Conservancy is actually based in Boston. Chris is based here, just like a lot of Cape Codders. They have fascinating backgrounds, and we love to showcase local folks who are doing cool things using technology to help our environment, help us be productive, and those sorts of things. So with that, Chris, please take it away.
Great.
Thank you very much.
Well, thanks for that great introduction, and glad to see you guys could all come out early on a Friday morning. So again, I'm Chris McGuire, and for the last 12 years I've been working at the Nature Conservancy on ocean conservation, but that's not how come I learned to love the ocean. So like a lot of people, maybe like some of you, I grew up spending my summers in the waters around the Cape and Islands, you know, on little boats and fishing and doing that kind of stuff. When I was in college, I actually participated in a study abroad program that's run out of Woods Hole called Sea Semester, where I was able to spend some time, 6 weeks on a research vessel in the Caribbean in the winter, which seems pretty nice on a day like today. And I actually enjoyed that so much that I decided that I would take some time between college and going to graduate school to work at SEA down in Woods Hole. And it turned out that that short stay was 17 years. Sorry about that, Mom. But in that time, I worked on the ships. I became a captain of their vessels, and so worked as a research vessel captain for about a decade. I like to say that being a research vessel captain is a great job in your 20s and 30s, and a horrible job as a dad. I was at sea for 6 to 8 weeks at a time, and so eventually I went back to graduate school and was lucky enough to be hired by the Nature Conservancy to sort of take my passion for the ocean and use that for ocean conservation work. The Nature Conservancy, for folks who may not know, we're large, probably the largest environmental nonprofit in the world. As Steve said, my office is in Boston, but we have offices in all 50 states and 79 countries. Started off as like a land trust type terrestrial organization in the 1950s, and then as it expanded, moved into freshwater and coastal and ocean conservation, and now are really focused on climate change. And we work across the globe to really reduce the barriers to those solutions to the climate change and biodiversity crises that will result in sort of solutions that drive us toward a world where people and nature can thrive. And that's kind of how we look at conservation. Is we're not just conserving nature for nature, we're conserving nature because it's important for all of us. So today I'm going to talk about fisheries. That's sort of the world that I operate in. When we talk about ocean conservation, it's a lot different than conservation on land. You can't like buy a piece of the ocean. So really, ocean conservation is really all about management, and it's really managing our impacts. That's one of the important ways that we help reduce stressors in the ocean, is to reduce our impacts. And fishing is a big impact, especially sort of bad fishing practices. And so we like to work on figuring out how we make fisheries more sustainable. And I do a lot of work here on the Cape. Steve said I'm from Falmouth, but this is a group, the Fishermen's Alliance, that folks might be familiar with, based down in Chatham. It's a group of small boat fishermen who are pretty progressive and I think are doing a great job of navigating, building commercial fishing businesses while also really caring for the environment. Fishing is still a big business. I learned recently that at the time of the colonial revolution, so in like the 1780s, fisheries represented 36% of all of the exports of the United States. There's a reason why there's a cod hanging in the State House in Massachusetts, because fisheries really were one of the principal industries that helped build the colonies. It's not quite that big anymore, but Massachusetts fisheries still provide $839 million of ex-vessel value. That means ex-vessel value is how much fishermen are paid for their catch, basically. And then you use a multiplier to sort of figure out what economic value is, and that takes into account the people who repair the boats and seafood dealers and ice makers and all that. And that turns out to be something like $2.5 billion of economic value that fisheries provide in this Commonwealth of Massachusetts alone. Barnstable County is actually the second largest area for fisheries in Massachusetts. Something like, I'm just looking at my notes, something like 52 million pounds of fish were landed in Barnstable County last year. And that's the second largest amount, second to New Bedford. New Bedford is actually the largest fishing port by economic value in the country. So Massachusetts is still pretty involved in fisheries. But to manage these fisheries, one of the things that we really need is good information. That's critical for management. The trick is that getting good information in the ocean is really hard. Fisheries science asks these impossible questions, like how many fish are in the ocean? That's like their day job. So imagine that as your day job. And counting fish is really hard. It's like counting trees, except for they're invisible and they move around and they eat each other, right? And so it's a very challenging setup. And the way we've counted fish for centuries is on vessels like this, where you go out and you try and catch a bunch of fish and you dump them on deck dead, and you wonder what they were doing when they were alive. Which, that was sort of the only way we could do this for a long time. Here's where the technology story starts to come into play. So because of technology, we have developed a lot of interesting tools that help us peek into the private lives of fish and better understand what they're doing when they're hidden under the dark, murky surface of the ocean. So what I'm going to do is I'm going to talk about 3 projects that I've been involved with in the last few years that are sort of related to fisheries and technology. Almost all of those involve Cape Cod fishermen, and many of them actually involve technology that is developed and built right here on the Cape. So let's just jump right in. Sorry, it's like these slides are a little dim and this room is so bright, but a few years ago, so this is sort of like act 1 of my 3-act story. A few years ago, even though I've made my life on the ocean, I learned a new noise. And it sounds sort of like this. It turns out that that's the noise that male codfish make as part of this intricate reproductive dance that they do to attract female codfish. It's like a quiet noise. Scientists call it a grunt. I think that's sort of like a sex joke because it's sort of like a clicking noise. But this is a sound that's made in the places where fish aggregate to reproduce. We call that spawning in fisheries. And those activities, it happens sort of in the same places year after year. And one of those places is about 30 miles sort of northwest of where we're sitting right now, kind of in the middle of Massachusetts Bay. So to try and imagine this is your view from there. That's about how far it is from Boston. And it's December. This spawning activity happens in the middle of the winter. The water temperature is like 40 degrees. And if you wanted to drop over the side and go down towards the bottom, maybe you're in 30 fathoms of water, so fathom 6 feet, 30 fathoms, about 180 feet of water depth. It's murky, and it's a little dark, but you might see something that looks like this. So this is a school of codfish. Fishermen call it a haystack, because if you look at this on your depth sounder, it looks like a big pile of fish that are massed on the bottom. And they have this intricate kind of mating ritual. there's like different behaviors in the daytime and at night. It's kind of like a single scene, and that like during the day, like the boys are over here and the girls are over there, and then at night they all get together and they go to the nightclub and like they, you know, they start to like get it on, right? So that's kind of how the spawning happens. From a fisheries perspective, it's really important that this type of thing is successful. This is how you build baby fish. Each female codfish can spawn up to 3 million eggs in a single season. So fish are incredibly fecund. They have tons and tons of little fish babies. But if you break up these aggregations, then those eggs don't get fertilized, and you know, you could crash a fishery really quickly by not bringing any new fish in. So from a conservation and fisheries perspective, having successful aggregations are really important. So I was approached by a group of fishermen from down in Scituate, actually, who were really concerned that the commercial fishermen, including themselves, were targeting spawning codfish. There was a change, this is a few years ago, there was a change in regulation. They used to have a closure that protected them. For whatever reason, that closure was lifted, and people were fishing really hard on these spawning fish. And they were really worried that that was going to mean that the cod that they'd worked to try and rebuild from a crash in the 90s were going to crash again. And so they reached out to us and said, like, look, here's our idea. If we could use science to show exactly where and when these fish were spawning, we could make like a really small closure that would protect the fish and let us still fish for, you know, flounders and other stuff on Stellwagen Bank and other areas. So let me just say, this never happens. Having fishermen reach out to like a conservation group and, you know, our like academic partners and say, what I want you to do is stop me from fishing. This is like never happens. So once we had the fishermen say that, we're like, okay, we're going to get to work. So we were able to find some state money and use some Nature Conservancy money and get to work pretty quickly. And so we need to sort of sort out what the tools were that were going to make this happen. So this part still needs a boat and some fishermen, but what you can see here is that we've just landed some cod, but instead of taking that beautiful cod and putting it on ice in the hold, these guys are putting it on a tank, putting the fish in a tank on deck. And that's because, here's where the technology comes in. What we're going to do is we're going to take these tags, which are made by a company that used to be called Bemco, but it's now called Innovasea. And they make these they make tags actually in lots of different sizes. So what you do is in the case of these cod, they surgically implant them in the belly of the codfish. Make a teeny little incision. This is like the size of a lipstick container. Make a teeny incision. You slip in the tag. The tag has a battery in it. Lasts about 5 years, and it makes a little bit of a pinging noise. It's the technology kind of works like the Easy Pass in your car, like the toll booth thing. So imagine this tag is like the thing you have on your windshield, right? And then what we do is we put a bunch of receivers, those are the toll booths in my analogy here. We put a bunch of receivers out in the water, and every time the tagged fish swims close to the receiver, it records the number of that fish that swam by. So this is the area that we're working with the circle here. So we're in the bottom right corner. We're kind of like east of Boston, west of Stellwagen Bank. We put out a lot of these receivers. So the colored dots on the right are all of the toll booths. So we papered this area with something like 60 receivers, which now we have to put these things out here in the winter and deploy them for 3 months and then haul them back up again. It's like a lot of work. But we hire a bunch of commercial fishermen to help us because they've got the gear. But even having those receivers doesn't cover enough area. So then what we did is we take this thing which is called a Slocum Web glider. These are actually built by this company called Teledyne Web based in Falmouth. These are underwater robots, basically. And what they do, and you can see this sort of on the screen here, is they are able to change their buoyancy. So how how much they float. And what that does is when it's less buoyant, it goes down. But instead of dropping straight down like a stone, because of those little wings, it kind of goes down and glides forward. And then it senses the depth, and when it gets close to the bottom, it turns, it changes its buoyancy, and then it rises slowly up. And again, because of the wings, it's going forward. So it moves kind of slowly, but it's almost silent. And it uses very little energy, so they can stay out a really long time. Like we put these things out for 2 or 3 months at a time. And then every now and then, every couple hours, it like sticks its tail up in the air so that it can connect to the satellite and figure out where it is and phone home and send some data back in. And what we do is we connect, we added, this is what the receivers look like in red. That's one of the toll booths that's listening for those tags. And then in green, on the front end of this thing, is a microphone. And that is listening for that sound that I made earlier, the grunts. So we tagged over 300 fish, which doesn't sound like maybe that many, but is a lot for this type of a project. But we know that every single male codfish is trying to attract the ladies. And so they're all making this noise. And so with the listening for the noise, all of the fish, not just the tagged ones, make that noise. So it's a way of covering a really large area silently and listening for the noise. The problem is that the noise that they make is pretty quiet. So you got to be like right on top of them to hear it. The transmitters, the Easy Pass thing works at about 600 meters, and the noise is really only audible for maybe like 150 meters. So you have to be right on top of them. And then, as you would imagine, you have 2 months of sound. You have like a recording of 2 months of noise. And so then you need to figure out how to find the cod grunts and all of that. And so we had somebody build an algorithm that goes through that noise and tries to separate out the specific frequency of that sound and separate it from the noises of ships going by and other gear and whales farting and whatever all the other noises are in the ocean, right? In order to pick those out. And so this technology is actually run by a lab down at Woods Hole Oceanographic, who are partners with us. So they operate the gliders, and so it's like a pretty Cape Cod operation. This is kind of the fast forward 3 years of research. This is sort of the end result. Remember that the question we're trying to answer here is, when does spawning take place and where? So the when is captured by this figure in the top left here. This is showing how many fish were detected by the toll booths, and the scale is a little bit cut off, but this is the number of fish per day that were detected in the whole array. And you can see that the peak there is sort of the middle of December. So this is kind of like a November to end of January kind of covers this activity. And then the where, this sort of complicated figure on the right is the where. The blue dots are the locations of the toll booths. And so the larger the dot is, the more fish were detected in that location, right? The green dots are the locations where the glider detected the tagged fish. And it might be hard to see, but there's sort of like a scribble of white that is underlaying this graph. That's the path that the gliders followed over the course of 3 or 4 months. And then the purple dots are the grunts. So that's where we heard them. So then what we do is we kind of look at this whole mess, and the good thing is the yellow line right there that you can sort of vaguely see, that is a closure that was put into place by the New England Fisheries Management Council based on this data that is closed to fishing in the time that our data indicated. So from November 1st till January 31st, everything inside that yellow line is closed to fishing. It doesn't capture every single fish, but captures a lot of it. So this is how you take like fishermen concerned about the environment, trying to make sure that there are going to be more fish for tomorrow, meld it with technology, and lead it right through to a management outcome. So this is a pretty cool story about how we use technology to figure this out. That's Act 1. We're going to jump to Act 2. This is a pretty famous painting, Winslow Homer painting. It actually hangs in the MFA in Boston. of like a guy in a dory, and there's a giant fish in the back of the boat there. That's an Atlantic halibut. Halibut are the largest flatfish species in the world. They can grow to 14 feet long, 700 pounds. This guy is like trying to row back to his dory here, row his dory back to the schooner. This might not look like technology to us, but in 1885, when this painting was made, is about the time that there was the first fisheries crash in the United States from overfishing. Fishermen were catching something like 5,000 tons of halibut a year using dories and schooners. Today, like last year, in all of New England, they caught 50 tons. That's 100 times less than what we were catching with schooners and dories in 1885. The fishery crashed and has really never rebuilt here in the US. Interestingly, in Canada, our Canadian neighbors, in the last 20 years, there has been an amazing recovery of halibut. Halibut is now certified by MSC. It's a hook fishery. It's really well managed, and they caught almost 5,000 tons of halibut last year in Canada. That might be why, if you go to the fish market or into restaurants these days, you see halibut on the menu, maybe more than you remember, from 20 years ago, because there's a lot more of it on the market. So halibut's like a really interesting species. Fishermen on the Cape started to say to us, like, something's going on with halibut, because we never used to catch them, and then it was like we would catch one a week, and then it was one a day, and now they're everywhere. Something's going on. So this is what the range of halibut looks like. We're way down here in the corner. This is all the way past Newfoundland. Every one of these dots is like a survey data point, but this is where halibut are, the range of halibut. The question for science that we were trying to answer with this project on halibut is really like, again, where do we see these halibut, and how much do our halibut in the US mix with the Canadian halibut? Fish, they don't really pay that much attention to borders. So our suspicion was that pretty much there was a lot of mixing happening. But it's an important question for management. We did know that there's some tagging. Tagging fish happens in a lot of ways. The simplest way that tagging happens is to basically use something that looks like a zip tie with a phone number on it. And you can tag a fish and then release it. And there had been fish that were tagged in eastern Maine that have been caught all the way to the far east on the southern Grand Banks and everywhere in between. So we knew that there was a pretty good amount of mixing. The technology I talked about in the last example, those tags, works really well when you're trying to look at a pretty small area. But remember, we had to put all those toll booths out. It's like a lot of work. You could never use that in an area this size. It's like so big, you'd need thousands and thousands and thousands of receivers to learn anything. So you had to sort of work with a different technology. So the tool that we're using here is called a pop-up satellite tag. They've actually been around for like 25 years. The way these work is they are externally put on the fish, and you put the fish back over the side, and it swims around with this thing hanging off of it for 3, 6, 12 months. And then at a predetermined time, it pops up and transmits information to satellites until its battery runs out. For a long time, we really got information that was not that different than regular tags, and that we knew where we deployed it, and it popped up and it said where it was, right? Which is like nice because you don't have to recapture it, but here's this is all the fish that we tagged with these satellite tags. And the arrows represent kind of where you started and where it popped up again. That's okay. And you can see some of them, it seems like they didn't go that far, and some of them, it seems like they went a long time, but we don't really know what happened at the time they were at liberty. Right? We know these fish migrate back and forth, but what happened in the middle there, right? At the same time, these tags actually collect information about depth and about temperature. And you can see this is a track, blue is depth and red is temperature. So this is like a 4-month track of what was happening. So you can see the fish is like going different places. But how do you turn that into some information you could actually use? Well, here's where we get into a little bit more technology. So we know how deep the water is in most places, right? And so let's say the tag says you're in 150 meters. You could identify where are the places that are possible that are about 150 meters deep. And maybe that's the areas that are shown on the red in the top figure here. Now temperature, these are fish that are on the bottom. So the temperature that's recorded is basically the same as bottom temperature. And our partners at the University of Massachusetts in Dartmouth run a high-resolution ocean model that can predict the bottom temperature at any location on our side of the Atlantic on any day. And so then you look at the temperature and you say, like, okay, the temperature at that one moment, maybe that tells you it could be in these places. And you combine those together and you get this likelihood, this probability of where the fish might be. That's still a pretty big area. On the screen on the right there, you can see the colors. That's still a pretty big area. But we know one other thing, right? We know where we started. We know where the fish was when we threw it over the side. So on the day we threw this over the side, east of the Cape, it probably wasn't south of Gloucester. And then we use a probabilistic algorithm that uses particles and says, like, okay, we know about how fast these fish swim. And we know where we started, so how far could it really be 12 hours from now when the next data point comes? And then you use that to look at the temperature and depth data, guess where it is, and you can sort of begin to piece together the pattern. And as we saw in that previous one, the temperature and depth changes. The Gulf of Maine has some there's a lot of big changes in the Gulf of Maine. There's places where the water temperature changes a lot, places where the depth changes a lot. And so this allows you to begin to piece together this story using sort of probability and statistics. And sometimes it allows amazing results. So here is a picture of 2 fish that were tagged about 170 miles apart, one of them off of New Hampshire and one of them off of Maine, in the fall. Each fish swam about 500 miles to the exact same location in deep water, like deep, 3,000 meters of water, just east of Georges Bank, and hung out there for like a month and a half in the middle of the winter. We know that halibut spawn in deep water, but we didn't really know where because we don't sample in 3,000 meters of water. People don't fish in 3,000 meters of water. This is like off the edge of the earth. And so this project is a new discovery, like one of the possible locations. The good news is nobody fishes there. So they're like doing their business all by themselves and nobody's bothering them, right? It's like pretty good. It's also clearly on the Canadian side of the line. So the line, the dotted line, is the Hague line. That's the boundary between the US and Canada. And pretty clearly, these fish from the US are swimming over to the Canadian side, out doing their business, probably with a lot of other fish, and then swimming back. So, you know, what you can see, and this is all these fish. One of them, the tag actually released out there. The other one, the tag released up off of Nova Scotia. But you can kind of pave this whole path together, and it kind of creates this interesting love story. Again, using technology. How am I doing for time? I should sort of wrap up, right? How am I doing for time?
8:35.
Okay. And so, yeah, so this is like, and the amazing thing about this, you know, you've probably heard, you know, there's a lot going on with AI these days. One of the things that's happened that probably many of you know is that there's this technology, this hardware called a GPU. You know, it's a graphics processing thing, which 10 years ago, the technology, the like computing power to run some of these computations would have been like only happening at a university. Because of these GPUs, like the grad student that I had working on this project could run this on his laptop. You know, this is why you hear about AI so much, is because the compute power on your laptop has now allowed you to do these incredibly complicated probability simulations, you know, on a simple piece of hardware that you have on your desk. Okay, so that's Act 2. Here's Act 3. Another project that we've been working on for a long time, and this is a little bit more of a management story, is using technology to help us understand a little bit more about fish and catch. So fishermen are required, commercial fishermen are required to report what they catch. Until recently, that was like on a coffee-stained piece of paper that they mailed in once a week. Now, actually, they use an app for that, which is good. And occasionally, regulators send a person out to go on the fishing boats. They call those people fisheries observers, to sort of independently see what's being caught and do some biological sampling and some other stuff. So, you know, those observers are pretty expensive. It's like expensive to like get a person out on a boat, and so small boat fishermen like this captain who we work with a lot out of Chatham, they reached out to us and they said, like, there has got to be a way to get this information with less cost. And so we started to work with them and fishermen across New England on this thing that we call electronic monitoring, where in essence, we're using video cameras to collect the same information that, or much of the same information that the fisheries observers are collecting. So, you know, cameras are not all that high tech. You know, we see them everywhere. You know, you go to the gas station, the convenience store, the bus station, the airport, like we're being watched by cameras all the time. But that technology hadn't really made its way into fisheries until recently. I like to say the great thing about using video cameras is that you can collect a lot of video. The bad thing about using video cameras is you collect a lot of video. You know, here you can see there are 3 cameras looking over the shoulder of this captain. We usually have 3 or 4 cameras running on a boat that are seeing like different parts of the boat. You're collecting, you know, petabytes of data that you need to figure out how to sort through. We do a pretty good job of tracking and getting data about the fish that we land. That's like what gets sold. That's where the money changes hands. You know, we have pretty good information about that. We have not very good information about fish that are discarded at sea. So most fish have a minimum size limit. And the reason for that is because we want fish to grow up to an age that they're old enough to like get in all that spawning conversation that we talked about in like Acts 1 and Act 2, right? Like we want fish to be able to reproduce. So fishermen try and tune their gear so that they catch the fish that are large enough to keep and not the other ones, but you know, it's not perfect. And so they end up with some of these, what we call regulatory discards. They have to discard these small fish. So in the case of the cameras, they set the fish on the measuring strip like this. The camera can see how long it is. We use a length to weight conversion tool to convert that length into weight and identify the species and collect the data that way. So it's like, works pretty well, but you could imagine on the review side, the reviewer sort of is like stopping the video, trying to, you know, look at those little black and red lines, figure out how big the fish is. Every time you stop the video, it takes time. Time is, we all know, is money, right? And so as you try and figure out how to move this forward, this is like a perfect opportunity for machine learning. This type of machine learning people call computer vision. So this is, you know, companies like Google have spent literally billions of dollars on computer vision for things like self-driving cars or facial recognition. But unfortunately, Google is not going to spend billions of dollars on fish recognition. This is like a niche market that nobody's going to make a lot of money on, right? So we end up having to find ways of investing in that ourselves. One good way to get the attention of the machine learning community is to run a competition, because everybody who's working in machine learning wants to get a job at Google. But one way to make your resume look good for a job at Google is to win a competition. And it turns out that the fish are actually sort of complicated. And so we actually ran a machine learning competition, and we put up a prize, you know, whatever, $50,000. We had 461 teams compete. We put up, you know, a couple hundred videos of fish, and the winner actually made this video that shows how the machine learning tools are drawing a box around the fish, drawing a line which measures it, and what you see flashing by in the numbers on the top is a comparison between what we told them was on the screen and what the algorithm determined was on the screen. And you can see that it's pretty accurate. They're counting the fish because we don't have to count a fish like 3 or 4 times. So they're tracking a fish as it walks through the image. They're identifying the species of the fish, and they're measuring the length. To be honest, the actual commercial deployments of this has been a lot slower than I wished. Turns out with machine learning, you can train an algorithm on training data, but then you show it something it's never seen before, and it gets confused. And so you have to kind of keep doing that. And so this is like a little bit of a work in progress. We haven't gotten this all the way through the pipeline, but what the competition did prove is this is doable. You know, and all of the companies that are involved in this are now investing their own money in developing these tools, and that's what we want. We want to be able to extract the important fisheries information for low cost, and we want other people to invest in that. So now these companies are investing in that. So, you know, I'm disappointed about the pace, but I'm always disappointed about the pace. I'd like things to get done like this, but actually it's actually still happening. Here's a crazy thing that is happening. I just wanted to know what kind of fish it was and how long it was. There's a group of scientists who are working to see if they can identify an individual fish, like a fingerprint, based on an image. This is from a paper that came out a couple of years ago working in aquaculture. And the little dots that you can see are, you know, this is, I don't know what kind of fish this is, some kind of trout. And in aquaculture, they often tag individual fish because they want to track health and, you know, that kind of thing. So they have these fish already tagged, and they use a camera to try and identify individual fish, like a fingerprint, using video. This is not something that we're doing right now, but all of that stuff that I was talking about tagging, imagine if that video that we're collecting about those discarded fish, if we, next time that fish got caught, you could say like, oh yeah, this fish was last caught some other day. This is like, we're so early on in computer vision and what we can do with these things. This is just like a tip of the iceberg into what technology like this kind of computer vision can do. This would really open up a lot of opportunity. You could take a picture of every fish that was landed and compare it to any fish that's ever been discarded, and you could begin to put this whole puzzle together at a species level. That's like where I think the future of some of this fisheries technology is, and this is happening in other parts of our life as well. So it's still super early days. So just to sort of wrap up a little bit, you know, pulling this all together, in the last decade, we've seen this explosion of technology in fisheries science. Again, some of it is developed right here. Some of the tools are developed right here on Cape Cod. Some of the elite scientists working down on my side of the Cape are, you know, heavily invested in refining this technology. I could have talked about on-demand fishing gear that is being developed to protect whales. I could have talked about environmental DNA that's being used. There's so much going on in the science space related to technology that it's sort of an exciting time to be involved. You know, our ocean has a lot of stressors, from fishing to shipping all those Amazon packages you people buy, to you know, energy development, climate change, you know, managing the stressors, understanding the system is really important for, you know, kind of having a healthy ocean that we go out and recreate in, that brings the whales to our neck of the woods. Like, this is, understanding is a really important part of conservation, and technology is really central to do that. You know, this is how we improve the management that supports thriving coastal communities, and you know, it's like the people and nature outcome that we're hoping for. And that's pretty much what I got. So I'm happy to answer. Yes.
You're clearly collecting a lot of data. Is this public domain data, and if so, is it available for researchers?
That's a really good question. It sort of depends. So fisheries are complicated because there's a little bit of like private business aspect of things. Fishermen don't want other fishermen to know exactly where they're fishing. That's like a pretty important piece of this. And so there are the laws about confidentiality require that you aggregate data before you can share it, which makes some of these data a little bit tricky to share. So it's not as publicly available as you'd like. What is publicly available is the output. So, we try and take not the raw data, but the data that comes out of it. Like, so in the camera example is a good one. We don't share the imagery, but the information about which fish are discarded gets aggregated and is used for scientists and stock assessments. And so the numerical data is shared, but not the video data. And there's a lot of confidentiality stuff around that video data. And it's pretty funny. We have we always tell the fishermen, we're not watching you, we're watching the fish. But, you still have people doing dances and stuff. The video reviewers are like, oh my God, you got to imagine on the Mary Jane, you can see this dude's got the moves, but it's pretty funny. But I don't actually see the video data either. Yeah, go ahead.
Do you have information on wastage and bycatch or improving things?
Sorry? Are we
improving things in terms of wastage and bycatch?
Yeah, so the way the rules are set up, and fisheries rules are kind of complicated, but we know that some percentage of the fish that fishermen catch and discard, some of them live, but some of them die, right? And so ideally, fishermen would have to discard no fish, right? That's sort of the ideal way. And so one of the reasons why we were really pushing to improve this data is when you only have an observer on a few of the trips, there's an incentive to not share all the information about the fish that you discarded. And the reason why is that the way the rules work, fishermen are allocated a certain number of pounds of fish that they can catch in a year. And every fish that they catch comes off of that allocation. So the fish that they catch and sell, and the fish that they catch and discard. So the reason why they do that is it creates a financial incentive for fishermen to tune their gear so that they have as few discards as possible. But if they're not reporting the fish that they discard, you sort of are avoiding that financial incentive, which is actually sort of cheating. But so by having this kind of technology, one of the outcomes is that we have been able to change the rules so that now 100% of trips are required to either have cameras or a person on board. And so now, that's how you reduce discards, is by daylighting them. And also using that financial incentive to really strongly encourage, fishing is a business, right? You're not, fishermen say, we're not catching fish, we're catching dollars. And so you don't want to catch those dollars and throw them over the side. So when you are actually required to report every fish you discard, and you just imagine those $1 at a time that you're throwing over the side, puts a lot of incentive on fishermen to tune their gear. And fishermen are amazing at adjusting their gear, especially when the incentives are right. So that's how you get to reduce discards. Yeah, Steve.
So you left us a little hanging with the cod story. Have you noticed an uptick in cod populations yet?
Yeah, that is sort of the unfortunate part is, the ocean's pretty complicated. Cod are, where we are, is sort of the southernmost extent of cod country. And so probably the thing that is driving cod dynamics more than anything else is climate change. As the water warms, just like us, fish have a temperature they like to live in. And when the water is too warm, they swim to where it's cooler. And so we're seeing cod populations like in Canada, in Iceland, in Norway are booming. They're not really booming here. And so while the spawning protection has been really successful, we're not really seeing an improvement of cod numbers that we wish that we were. And probably climate change is drowning out that signal. But it's really hard to separate those. And that's one of the biggest challenges with climate change is it's hard to separate one driver from another. So it's not a great story for cod right now. So it's we'll wait and see.
So my question is actually kind of related to Steve's, but in terms of the cod, are you using any of this data to do predictive modeling or anything around the future state with it? If you were to change the boundaries of the protected area or whatever?
Yeah, we haven't done, that's a good question. I mean, the stock assessment scientists do predictive modeling to try and, because again, fisheries science is like an impossible, first question is how many cod are there, right? Which is like pretty hard to start with. The next question they have to answer is how many cod could I catch next year and have there be more cod in the total population anyway, right? So they have to sort of do a little bit of lookout. The one thing about protecting spawning, it's like obviously a good idea to protect spawning, but just protecting the spawning doesn't mean that more fish are going to grow from being eggs to big fish. A lot of environmental dynamics happen as well. So cod eggs actually float for 30 to 45 days after they are fertilized. So from that area off of Boston, they're going to float, and then where they settle out is really important. And so if they settle in like Plymouth or in the bays off of Cape Cod Bay, great cod habitats, places to hide, they're in the estuaries, you could see a huge, what they call a year class. Like you could see 1 year of cod and have a lot of them. If the winds are blowing the wrong way or whatever, and they all go out east, out to sea, you could see almost no survival. And so that's why every fish has 3 million eggs, because it's like low probability and you got to broadcast a lot of them. But so they don't really do, we know that we actually monitor this site, so we know that there's still spawning happening in this area, and there are other areas that are closed for spawning for cod and other fish. So we don't think that is changing right now that much due to climate change, at least in the short term. But how we, it's like we're sort of doing the best that we can to set the environment up for success, but then there's like a lot of other variables that are totally outside our control.
So in the absence, I guess, of a population increase or like a reduced population decline, I guess, how are you measuring success of the boundary area?
Well, like I said, we monitor, well, not we, the state of Massachusetts does, and the federal government, NOAA Fisheries, monitor with surveys in these areas. And so we basically say that it's successful if spawning is still taking place inside the box, right? So what we're trying to do is protect the activity of spawning. Unless that center of spawning moves someplace else, you're still protecting it with the closure in the place that it is. It's just like, I wish that was all it took to make cod rebound, but it's complicated. Does that answer your question?
Yeah, I was sort of curious, how you're using that data to measure and kind of have a quantifiable outcome.
Yeah, the other thing that we can do is we measure, like I said, those eggs float for 30 to 45 days. We do plankton sampling, and so you catch fish eggs in plankton sampling, and so over time, you build a time series out where you can say like, oh, look, there were a lot more fish eggs. And so that's one way. We have seen an increase in cod eggs in this area, in the last few years. And so that's a good sign. But again, it's like only one step in a multi-step process. So that's another really good way of monitoring the activity itself. Yeah.
What are your thoughts on using it? I know you get commercial fishermen. What about the recreational fishermen? How can they help you with data capture?
Yeah. We do some work with recreational fishermen. The challenge is, it's sort of a challenge of scale, and so it's a lot of work. Every fisherman that you build a relationship with, it's like there's a time sunk in that. And so if I am working with one commercial fisherman and they're going to catch 3,000 pounds of cod on a trip, that's like a lot of data that you can collect. If I go out, cod fishing in the winter, which I've only done a couple times because it's really hard work, I might catch like 2 cod. And so the time that we invest in working with recreational fishermen on this type of project, it's like hard to get a payback. There is a cool project that we're involved with recreational fishermen on a species that isn't commercially fished. False albacore is like, albies are like a really popular sport fish. People don't eat them, they taste horrible. But it's like a fun game fish. They're a part of like the tuna family. If anybody's a fisherman, yeah. So we're actually working with a bunch of recreational fishermen and charter fishermen to do like one of those sort of simple tagging projects where you just put basically like the zip tie with a phone number in these albies, to try and figure out, like, do the albies that we see here, are they the same ones that they catch down in North Carolina? Spoiler alert, yes, is the answer to that. But that's like a type of fish. If you didn't work with recreational fishermen, you'd collect no data because there's no commercial fishery. So that's how we sort of manage the two different groups. Yeah.
Do you know of any efforts to take this research and start to commercialize it and use it across the world, for example?
Well, I mean, I think the commercializing is in the hardware development. So, you know, the tags, for example, like the company that makes those tags, like in the toll booth example, you know, they are working, you know, they are the dominant company working that make these tags. This is like a sort of a niche market. Even though fisheries happens all over the world, like the number of people who are buying tags is pretty small. And so that one company pretty much owns this market. And the cool thing about that is that at our receivers, there are other projects that are tagging sharks and sturgeon and, you know, all sorts of other fish. And so we actually get other detections of fish, and there's a database where we upload those detections. All of the detections that we get uploaded to a database. And so if I'm a scientist and maybe I tagged a white shark, maybe I work for the White Shark Conservancy down in Chatham, and I tagged a white shark off of Chatham, if one of my sharks pinged in the array, I would be able to get an alert from the database that said, like, hey, one of my sharks was just picked up there. So the commercializing is less on like the doing the work that I do and more on the development of the technology, because that's the only place where there's scale, I think. Yeah. See.
So what other countries, are other countries as interested as the United States is in this type of information?
Definitely. Yeah, so, I mean, like a lot of things, you know, you could imagine this sort of first world countries or whatever. I mean, there are a lot, fisheries is big business. Yeah. And there are a lot of countries that have really, really good fisheries management. I am participating in, I actually chair an international working group related to the video camera stuff that works across the North Atlantic. And we have members from, you know, the US and Canada, but also from almost every European country. And, you know, so all of the European countries use all of these technologies. You know, Japan, you know, Australia has incredible fisheries management.
So I guess, I mean, so what you hear about as far as violators are China and Russia with the factory ships, and I don't hear you mentioning that. So.
Yeah, so that I think that they invest less in, you know, kind of like daylighting what's happening in fisheries. You know, there's a lot of bad actors in fisheries. You know, we are working. You know, the Nature Conservancy again is a big place. We have a team that is using the camera technology in the tuna fishery globally, and we've been running projects in, you know, in the Pacific Islands, you know, in the Marshall Islands, in French Polynesia, in the Seychelles. We're running a project in Chile. We're running projects off the Spanish coast. You know, so that technology is moving pretty broadly. And one of the ways that we do that is, like the way that conservation works a lot of the time, what I do is I try and demonstrate, like with a small project, an idea of how you could do something differently. And then we try and scale that up through policy work. And so in the case of the cameras, it's like, okay, let's figure out whether or not like this actually works for fishermen like this. And then we try it in a few other fisheries. And then you go to these international working groups and you say, you should require this on your vessels if you want this kind of information. And that's exactly what's happening. So, you know, there's a lot happening with that type of an approach. So we sort of demonstrate how a technology might work, and then we sort of export the knowledge around that. And then there are private companies who are like building the cameras and doing the video review and that other stuff. But yeah, so it's happening in a lot of places. Yeah.
Just another, thanks for mentioning the Fisherman's Alliance, another plug for it. It's a great organization on the Cape, and they offer a lot of fun events.
Yeah.
I went to one of their SCUP events, so they're trying to promote, you know, species or stock that's available that's less popular.
Yeah, Meet the Fleet type events, that's what they call those. It's sort of monthly where they'll have a fisherman and a chef and some like delicious morsels and talk a little bit about one of those fisheries. So we work really closely with those guys. They also have a really fun event in the summer called the Hooker's Ball. Yeah, in August, which is like a big, gala fundraiser type event, and they have, all sorts of fishermen there and good seafood and a good band and everything else. So, yeah, we're great partners to those. Strongly support.
Chris, that was wonderful, fascinating. Thank you again for joining us.